Very simple question. Very simple question. The number of diagonals of a polygon are nothing but 35. Then find the number of sides of the polygon. We don't know the number of sides of the polygon. Let them be n. To find out the number of diagonals, you need 2 points because n vertices will be there. It is NC2. 2 points are chosen. But in this one, the sides will also be there. Side is not a diagonal. Side is not a diagonal. That is why it is to be subtracted. NC2 minus n. Just now I explained you. That's what is simplified, and it was given to be n into n minus 3 upon 2. Which is here given to be 35. Understand that, please. If a polygon has 35 diagonals, then the number of sides of the polygon means n into n minus 3 upon 2, which is nothing but n into n minus 3 is equal to 70. N into n minus 3 is equal to 70. This 70 is nothing but 10 into 7. So n into n minus 3 is equal to 10 into 7. So n is equal to 10. N minus 3 is equal to 7. So what should be the answer there? N is equal to 10. So the number of sides, the number of diagonals are 35. The number of diagonals are 35. Then the number of sides will be 10. So what should be the option there? 10. 10 is the option. That is option D is the correct one. Next one. The number of triangles whose vertices are the vertices of an octagon. The number of triangles whose vertices are the vertices of the octagon, but none of whose sides happen to come from the sides of the octagon. None of whose sides are happen to come from the sides of the octagon is. Before answering this question, let us have a general problem of n-sided polygon. Go to the next slide. Now go to this, please. If there are n points on a circle, then find the number of triangles that can be formed by using these points such that no two consecutive points are chosen. What does it mean? There is a circle. On the circle, how many points are there? N number of points are there. Now you have to form the triangles in such a way that there should not be 2 points consecutively chosen. That means this is we don't want. This we don't want. But we need this. Because these two are not consecutive. In between these two there are 2 points. In between these two there are 2 points. So understand. Now, how many such triangles can be formed? So for your better understanding, what I do, I'll take a hexagon. Because hexagon, you can clearly construct such triangles. For the better understanding, I have taken a hexagon. Hexagon, how many sides it has? 6 sides. How many vertices it has? 6 vertices. 1, 2, 3, 4, 5, 6. 6 sides, 6 vertices. Now, how many triangles can be formed in such a way that no side of the hexagon should be the side of the triangle. That means if you draw this is one triangle which we need because these two are not consecutive. In between them, one vertex is there. Now, if you see, this one also needed. So, how many triangles can you see now? This is first triangle needed. This is second triangle, it is also needed. Do you understand? You can see a clear star there. Okay. So, according to our question, there are only 2 triangles that can be formed such that no side of the hexagon should be the side of the triangle. Now, let us apply the concept of combination now. Combination. How many vertices are there? 6 vertices are there to form the diagonal or to form the triangle. To form the triangle, how many vertices are needed? 3 are needed. Taken. 63. 63 is nothing but 6 into 5 into 4 upon 3 into 2, which is getting cancelled. That is 5 into 4, 20. So if you apply the combination, you are getting 2. But practically, if you see, these are only 2 triangles. So what is happening here? What is happening here? Minus. If you see carefully, let us take this side AB. For AB, with AB as side, the triangles are also included in this one. With AB as a side, the triangles are also included in this one. So, which are not needed, but they are included in this one. So, how many such triangles can be formed with AB as side? Let us see. With AB as side, let us see. That means you must not take these two. You can take. That means this is not taken, this is not taken. But this can be taken like this. This is one triangle. And this is another triangle. So understand, with the AB as side, how many triangles that can be formed? Here 2 triangles can be formed with AB as side. So how many such sides are there? BC is there, CD is there, DE is there, EF is there, AF is there. 6 are there. That means for AB you are getting 2 triangles which have AB, that is the side of the hexagon as the side of the triangle, so which is not needed. So each 2, how many are there? 6. 6 into 2 minus. But you will find such triangles which have, I'll draw this separately so that you'll understand it in a better way. What I did now, I have taken AB, I am counting those triangles which are not needed. This is one triangle. This is another triangle, not needed. That means with the AB as side, this is one triangle. With AB as side, this is second triangle. So 2 triangles not needed. So how can we take n is equal to 6 as there are n sides? For the better understanding, I am taking an example. Now we will generalize it to n. We will generalize it to n. Your question answer, Miss Lalita. We are generalizing to n now for the better understanding. 2 into 6. Now, similarly, if you have same like hexagon, this is 2 sides are there, A, B, C. This is one triangle formed with 2 sides. Another triangle, another triangle, another triangle, another triangle, another triangle with 2 sides as common sides. Then it is minus 6. So what should it be? Minus 12, minus 6. What should it be? Minus 18. What should it be? 2 triangles. According to our construction, you have got 2 triangles. Now let us generalize this to n sides, Miss Lalita. Just listen to me now carefully. N-sided polygon. This is nothing but a polygon. On the circle also, the polygon will be formed because no 3 points will be collinear on this case. No 3 points will be collinear. So from this one, we will find out NC3 minus here. How do you get 6 here? 6 is 6 sides. For n-sided, n sides into. For AB, these adjacent points are not taken. AB adjacent points are not taken. That means it is nothing but 6 minus 6. Totally 6 are there. So how many points are avoided? 4 points are avoided. So 6 minus 4. C. How many points are taken? 1. 6 minus 4. C1. So it is nothing but n minus 4 C1 minus what is 6 here? 2 sides form 6 triangles. I have shown it here. So for n sides you will form n. So if you simplify this, n of n minus 1, n minus 2 upon 3 into 2 minus n into n minus 4 minus n. If you simplify this, you will get as you can understand the answer now. It is NC3 like 63 minus n into, that is 6 into, what is 6 here? 6 sides. Here, how many? N sides. So you may be getting confused if I draw like this. So n sides means they will be formed. This is nothing but a hexagon only. I present it in another way on a circle. So here in place of 6 you must get n, And in place of 6 minus 4, you must get n minus 4. 1 point is taken to form the triangle, that is 1 minus 6. Here 6 triangles are formed. 6 triangles are formed. That is why minus n. So if you simplify that, you can see that it is n of n minus 4, n minus 5 upon 6. If you can remember, it will be better. If you can remember, it will be better. So if you go to the previous question now, Sixth question, the number of triangles whose vertices are at the vertices of the octagon, but none of whose sides happen to come from the sides of the octagon. What is n in this case now? What is n? Please apply and tell me the answer now, because you are asking the doubts. Let me see how many of you answer this question based on this formula, please. Here it is an octagon. For an n-sided polygon, I have derived the number of triangles that can be formed in such a way that no side of the hexagon is the side of the triangle. So that means this is one required triangle. Like that, because these two sides are not included in this triangle. Any side of the hexagon is not included in the triangle. So now it is an octagon. The same concept. It is an octagon means put n is equal to 8. Put n is equal to 8. So this is what you will understand now. 8 by 6 into 8 minus 4 into 8 minus 5. 8 minus 5. Simplify that, you will get the answer. So the presentation of the question is different. This is same as the 7th question. The number of triangles, here the number of n points are lying on a circle. Lying on a circle is same as the forming of a polygon. Both are same only. So for that one, you can take this as a trick to apply. That is n into n minus 4, n minus 5 upon 6. Okay. Go to the next one. The number of rectangles that can be formed on a chessboard. The number of rectangles that can be formed on a chessboard. So Aishwarya's question will be answered through the mail, and let me see that, and I'll answer that question. Let me I'll give a reply to that one. Okay, now in this one, because the time is not sufficient to discuss that. The number of rectangles that can be formed on a chessboard. On a chessboard, you know, 1, 2, 3, 4, 5, 6, 7, 8, 9. Vertical lines will be there. Similarly, 1, 2, 3, 4, 5, 6, 7, 8, again 9. So, on this one, we need the number of rectangles that can be formed. Number of rectangles that can be formed. Follow this carefully, please. This is one square, of course. Square is also a rectangle. This is another rectangle. This is one rectangle. This is another rectangle. This is another rectangle. So this is another rectangle. So like that, how many rectangles will be there on the chessboard? That's what is needed here. So here, how many lines or vertical lines are there? 1, 2, 3, 4, 5, 6, 7, 8, 9 vertical lines are there. How many horizontal lines are there? 1, 2, 3, 4, 5, 6, 7, 8, 9 horizontal lines are there. So to find out the number of rectangles, whatever the rectangle you take, there will be one set of parallel lines. And in the second set also 2 lines will be there. To form the rectangle, 2 lines should be taken from the vertical set, 2 lines should be taken from the vertical set, and 2 lines should be taken from the horizontal set. Understand it? From the vertical set, 2 lines to be taken. From the horizontal set, 2 lines to be taken. So, first operation, what I do? I'll choose 2 lines from the horizontal set. First operation, I've been repeating that whenever you solve any problem related to permutations and combinations, you always split it into operations so that it will be more comfortable to you. First operation, what we are doing, we are choosing 2 lines from 9 lines. Chosen. It can be done in how many different ways? 9C2 different ways. Second operation, this is horizontal lines we have taken 9C2. From the vertical lines also, you can choose 2 lines in how many different ways? 9C2 different ways. So first operation can be performed in 9C2 different ways. Second operation can be performed in 9C2 different ways. These 2 operations, one after the other or simultaneously, can be performed in how many different ways? 9C2 into 9C2 different ways. What is 9C2? 9 into 8 upon 2 into 9 into 8 upon 2, which is nothing but 36 into 36, which is nothing but 1296. You can see the answer there. It is option B. It is option B, 1296. So the number of rectangles that are present on the chessboard are 1296. Now if you see the next question, the number of squares that can be formed in a chessboard. The number of squares that can be formed on a chessboard, just you go through the question and answer it on your own, and if you get the answer, that will be good. Otherwise, we will see this in the next class, and we will be discussing more and more questions only in the coming 2 sessions. We'll be discussing more and more questions only in the coming 2 sessions, along with concepts. So you try this one. I have explained you the number of rectangles, and 9th question, which is on the slide, you can see the number of squares that can be formed on a chessboard. You find it out, please. Okay, if you get the doubt, we will clarify that in the next session. Next 2 sessions will be the problem solving sessions, and the Miss Aishwarya's question will be answered through the mail, otherwise in the next session.